You don't really want to introduce me, do you, Tim?
No, not really.
Okay, let's just,
Everybody knows Tom.
yeah. Are we ready? Do we have time here? Waiting for my lovely wife to arrive, but Manny Padron is bringing my wife, so I think after 3 hours of listening to his jokes, she just grabbed his wheel and they drove into a bridge abutment or something. Those of you know Manny will appreciate that. Okay, I have one more thing to do now. I'm going out and have a smoke and go to the bathroom, and then I'll be back. Okay. I have to start my little device. That looks all right, but I don't think it's going to go in there. Yeah. Yep, okay. Thank you. Thank you, Mike. It's my 27th year of speaking at this thing. One of these days I'll get it right, but I want to thank Mike Smith. He's been here, I think, for all 27 years doing our audio-visual back when we had slides and everything, and it really is flawless. I mean, people like Mike and I and Tippy have talked all over the world, and that's the key guy, really.
That's true.
So I really appreciate it, Mike. Okay, we're going to talk about gas giants. Now, when Tippy and Tim got together, and they asked, there's a lot of stuff going on Jupiter and Saturn, which are the gas giants. And they said, well, who can we best get to talk about the gas giants putting on a show? And, you know, it's the gas giant himself, right? To prove that. And as my wife Maureen can also attest to that, right? Okay, so anyway, let's first talk about Jupiter, which is a real gas giant. It's 88,000 miles in diameter. And the images you're going to see, most of the pictures, will have the south up, as God intended, through an amateur telescope. And the Jupiter's east will be to the left, which will be the Earth's west, okay? So, and also when you trip over the cord that runs your clock drive, that's the way the planet drifts. Okay, and the rotation of the planet is also to the left or to its east. Planets rotate to their own east. So that's kind of just give you an idea of the orientation. And there are certain features on Jupiter when you see it through a pair of 7x50 binoculars that you need to know about. Well, you don't need to know them. Frankly, I wouldn't care, but I got to talk about it. So anyway, you have two dark belts, and they surround a bright zone called the equatorial zone. You say I have system 1 there. That's a rotation rate system. Jupiter is made of gas, and therefore its equator rotates a bit faster than the temperate and polar regions. So they have arbitrarily called the equatorial zone system 1. It goes around about 10 hours. Don't ask me the exact numbers because I'm old, I can't remember these things. It takes about 10 hours for one rotation. And then the rest of the planet is system 2, which is a bit slower by maybe 4 or 5 minutes per day. Less rotation, and now we have system 3, which is the one the professionals use and most of us are using now, which is the radio rotation. They've discovered that Jupiter has a hot spot on the radio band, and that is a very precise timing for its rotation, and that's kind of what everybody uses now to relate where things are on Jupiter. Since it's made of gas, hard to pin down where stuff is, and this is the reason they have these 3 systems. Also in the equatorial zone, you have these bluish-looking things called festoons, and Jose Alvarez these blue features were named after him. He was the head of the Jupiter section of ALPO for many years, and he thought there were water holes, which it turns out they might well be, that you're seeing the water layer in Jupiter's atmosphere through them. Okay, then we have the south equatorial belt, which is kind of what I'm going to be talking about mostly. The north equatorial belt, south equatorial belt south, the south equatorial belt north. SEB is sometimes split in 2 and divided by a zone, a bright zone. And then you got the tropical zone, temperate belt, you know, yada, yada. It gets very confusing, but really all you got to remember are these 2 belts, north and south equatorial belt. Okay, then we get the south-south temperate belt. Oh, geez. Now, Jupiter, 88,000 miles in diameter, goes around in about 10 hours. So it's really not this fast, but it really is moving. And you would imagine that the wind speeds on Jupiter are pretty intensive. Here's Damien Peach, who was here a few years ago, the great astrophotographer from England, made this little montage over a period of 3 days, taken with his telescope, You can see, here's the equatorial zone. South equatorial belt is missing here, and the great red spot. And look at how the different layers are rotating at different rates. See that? Jupiter. A little better picture of it here. Here's the red spot going around. And you can see this, I mean, just violent activity going on Jupiter because the winds are tremendous there. They're up to 150 meters per second. What? Okay, to digress, being a taxpayer, a real taxpayer, a very bitter taxpayer, back many years ago, I don't remember when it was, Mike, when Voyager flew past Saturn. Okay, I was watching television, NBC, and they're going to have Dr. Snoozlesnoo or whatever it was. He was going to talk about the wind speeds on Saturn, which they'd just gotten, you know, from the station. I thought, well, this is going to be really cool. This clown gets on, he's talking about 15 to 20 meters per second. Everything is in meters per second. Now, you know, it just really irritated me because I'm paying for this. And, you know, I could picture a lot of my relatives back in Illinois. I said, what did he say? You know, what's that meter per second thing? Take out the empties, would you? Okay, anyway. So as a rule of thumb, anybody know what 100 meters per second is?
60 miles an hour.
Just multiply it by 2 to get miles an hour. So 100 meters per second is 200 miles an hour. Roughly. It's a little bit more than that, but, you know, so that way you can get around some of these clowns who are trying to snow you with this fancy talk. Okay, never mind. Here's a shot I took last night. Isn't that incredible? You can see the different wind speeds. And, you know, this is the equatorial zone, which has probably the highest winds, well, except for a couple. And you get a Coriolis effect because the winds are more here, and then the winds are less in these zones, and you get actually rotation. You can see that very distinctly in the great red spot, but that's called a Coriolis effect. The whole planet is like this. It's nothing but a bunch of rotating wind vortices, high pressure, low pressure systems.
Whose video is it?
That was the Cassini going toward Jupiter. Galileo. Yeah, not Cassini. I get those guys. They're all Italian. I get them mixed up. Okay. When you look at Jupiter, to me it's kind of counterintuitive because the dark belts are actually lower down than the zones. So the bright zones tend to be higher. You get an upwelling of the warm atmosphere from Jupiter's interior to form the zones. The gas condenses out as ammonium crystals, and then you get a downwelling of this dry, cool material, downwells to form the darker belts. Why they're dark, why they're colored, they really don't know. There's a lot of organic chemistry going on in Jupiter's clouds, but they're not really sure, you know, why the colors are there. Hydrogen cyanide may be one of the things that causes the red color, and which would be good because hydrogen cyanide is a real good prebiotic chemical before life. I mean, it also kills people in California, but gas chamber, but it's also, a lot of these things are talking about some of these gas giants being cookbooks for life. Anyway, this just gives you the idea of the atmosphere. 100 bars, which is 100 times Earth's atmospheric pressure, which is still pretty high up in Jupiter's atmosphere, is water ice. And then you go to ammonium, and then finally you get a layer of ammonia ice up here, and smog, whatever. But basically it's the ammonia ice cooling, drifting down, forming, you know, sinking down to form the belts. Okay, we have the great red spot, which I talked about, and most science programs and books say, oh, it's a big hurricane on Jupiter, because we've seen it swirl, right, like that. It's going counterclockwise. And those of us who live in South Florida are well aware that hurricanes go counterclockwise in the northern hemisphere. But this is in Jupiter's southern hemisphere, so it's not a hurricane, it's a high pressure system. And it also sits way above the cloud belts and zones. It's a very high feature in Jupiter. You can see it's gobbling up all these little critters here. It's just really violent. Okay, so now I'm going to talk about 3 things on Jupiter. One is spots. And this is the way Jupiter looked in 2005. You had the great red spot here. You had something called oval BA, which nobody really cared about. The history of the white ovals is kind of interesting. They're in the south temperate belt of Jupiter. They were discovered in 1939 by a guy named Elmer Reese, who died a few weeks ago. He discovered a whole lot of stuff. He was an amateur astronomer who turned professional and became sort of a Jupiter guru for many years. And these three ovals were called F, A, D, E, and B, C. The reasons they were called that is that in 1939, each oval was almost 120 degrees wide. So they named A is the first oval's front of the dark spot that separated the first oval, AB. The dark spot was called A, B, C, D, E, F. But then they found the ovals were shrinking and shrinking and shrinking, so the dark spots lost any interest in naming these dark areas in between, and the ovals took on the name F, A, D, E, B, C. And they began to shrink it really dramatically in the 90s, and we all thought, are they going to go away like a soap bubble? Well, DE did about 1998. 1999, FA and BE were approaching one another, and in 2000, they merged to form oval BA. Now, I know it's exciting. We maybe should take a break just to let everybody calm down. Do you want me to repeat that? No. Anyway, then this guy comes along, Christopher Go, okay? Amateur astronomer in the Philippines. And in 2006, he says, whoa, you know, we imaged Jupiter, and oval BA had turned red. And he dubbed it the little red spot. And this got professionals really interested, to the extent that Chris is on the Hubble imaging team now. And he's presented papers at professional meetings. I mean, the guy's more than just a guy who says, oh, it turned red. He has done a lot of really good work. So anyway, the little red spot was a major discovery. I imaged it a number of times. This is in methane. I'm going to do a lot of methane band images. 889 nanometers plus or minus 9, very narrow, far infrared band. And I'm not really interested in methane gas, despite those first slides I showed you. What methane really shows you is the altitude of what you're looking at. So when you see this is the great red spot. It's high up because it's not the methane is not absorbing the light from it. It's catching the reflected sunlight off the very high layers in the atmosphere. And oval BA was also high up. And has a counterclockwise rotation. It's like a mini ultra high pressure system, and it's still there, and it's passed the red spot many times, and the red spot hasn't been able to gobble it up. So that was kind of neat. So 2008, we had the great red spot, oval BA, and then along comes Anthony Wesley in Australia, and he discovers a little red spot. Now, this is kind of unusual. We're getting all these spots occurring in Jupiter in the last few years. And again, the little red spot had the same characteristics. It was high up in the atmosphere, counterclockwise rotation, and we call that the baby red spot. But alas, there's a Hubble image of it. Alas, the baby red spot didn't last long. Within a couple months, it was approaching the big red. And this is a composite that actually a professional did of amateur images because they didn't have any Hubble images of this. And you can see the baby red spot being gobbled up by the big red spot. It was kind of tragic. We all felt bad. Went out and had some drinks, and but that's what happens. So that's kind of neat. I mean, the quality isn't all that great, but we can see it. It's something that actually happens in the solar system. Okay, the second thing is impacts, things whacking into Jupiter. And Jupiter, again, 88,000 miles in diameter. You can fit, 315 Earths in it. I forget what the mass is, but Jupiter accounts for the vast majority of the mass in the solar system. I think something like 95% of the mass in the solar system is Jupiter. So it's been called by many Earth's bodyguard because it has really prevented us from a lot of Chicxulub-like events being, the Earth getting whacked by asteroids and various other objects. And in 1994, Jupiter proved that it was Earth's bodyguard because it captured a comet. The comet was going by, Jupiter's gravity captured it, went around Jupiter once, and the gravity ripped the comet into 21 different fragments. And starting on July 17th, 1994, fragments started whacking into Jupiter's atmosphere. We all thought, when we heard about this, Steve Edberg is the one who told us about it. We're out in California. He comes running in from JPL. Oh, there's a flash. Jupiter's going to get hit next year. And the asteroid, and the fragments they're about, maybe the biggest was a mile across, 2 kilometers. We all laughed. The guy was on a cocktail napkin. You know where we were. He was lying on a cocktail napkin and pictured Jupiter as an elephant. There's a mosquito hitting it. We all, Well, it turned out the mosquito was going 100,000 miles an hour. So there were just tremendous explosions. These fragments whacked into Jupiter's atmosphere going at that rate. The kinetic energy was released. Enormous explosions occurred. And then the debris from the meteoric material itself flying up into Jupiter's atmosphere and just spread out along its cloud deck. And this is all the different, that looks like a couple of eyes, and one of these looks like a Klingon battle cruiser somewhere. It's kind of neat, the shapes these things took on. But this was really a major event, and we had a couple of folks who were among the first in the world to see it. Chippy Dioria, the handsome gentleman there, and Jeff Bish. And that was at Jeff's house when he lived in Homestead. And you were right up there. I forgot exactly what number. Jeff was the first.
Jeff was first and Carlos was second.
Yeah. Carlos the Jackal Hernandez was second. And Chippy was the, well, whatever. Anyway, it was a really neat event for all amateurs and professionals. I did some imaging of it, and this is with a Lynx camera, you know, the old days. And infrared, they were dark. But in methane, these impact areas were very bright. And I just started using methane, so I asked one of the professionals, I said, does that mean they're really hot, you know, the explosion? He said, no. I said, it has nothing to do with temperature. It means they're high up. So these plumes are extremely high, the altitude, thousands of miles above Jupiter's cloud date. And that's why you see them bright in methane. Again, there's the red spot, and that's EO, or one of the satellites. Okay, so the experts, quote, unquote, said, well, these impacts maybe every 1 or 2,000 years they might hit Jupiter and all, you know. So historians started going back into the literature. And of course, the one thing about NASA, I'm sorry, Mike, but Chick Capon used to say, NASA's really great, but they don't read the history books, which is really true. And we went back to this guy, Giovanni Cassini. And he made a drawing in 1686 of Jupiter. And it's kind of like Troyanes. Where's Dan here? Yeah, it's like one of you. Anyway, there's this really dark thing, and he described it in his notes. He said, it's darker than the shadow that the satellite casts on the planet. And over about 3 weeks, he sketched how that thing evolved, which looks suspiciously like how those Shoemaker-Levy 9 impacts evolved. So, but people have poo-pooed this. We don't know, but it may well have been an impact that he observed on Jupiter. This was the telescope he used. This is a drawing of it. Paris Observatory, I think it was a 3 or 4 inch refractor. It was the first go-to telescope. Because they had all these, 50 guys, and he said, okay, go to that way. But it's amazing, that drawing, to do that drawing with that kind of instrumentation is amazing work. It really is. Okay, and George Airy, who blew it with Discovery of Neptune, did record that he saw something dark, very dark feature on Jupiter. We don't have any drawings because he was Astronomer Royal and above making drawings. So we have no evidence of that either. And then on July 19th, 2009, Anthony Wesley again from Australia came along, Newtonian I might add, and he saw this. And there's a little dark blotch up there. Now, he lives in Australia, Crisco lives in the Philippines. Time difference is about 10 hours between Miami and Australia and the Philippines, roughly. And Jupiter goes around in 10 hours. So we can each observe each night, we're seeing the next rotation of Jupiter. So we can watch, that's kind of neat. The night before, 10 hours before Anthony's discovery, it was my daughter's birthday, and I took the whole family, grandchildren and everybody out to Captain's Tavern for dinner. Now, you ever eat at Captain's Tavern, it's wonderful food, but it ain't cheap. So I was sitting at the end of the table, kind of mentally calculating what the bill would be, ordering pina coladas. After 4 pina coladas, I get home and I said, well, maybe I should image Jupiter. Nah, go to bed, so I missed this by 10 hours, becoming famous and rich. Anyway, my wife was a great help. She said, it's your own damn fault, so usual supportive. Anyway, Wesley still would have got credit because I probably would have been 2 days before I processed the image. And hey, I might not even noticed it. Wesley processed his image and he saw it and he recognized it for what it was. And within a few minutes put out an alert, he just said, hey, we might have an impact on Jupiter. So that's really cool. I did image it a couple days later, and again, methane band, very high. And that helped verify that it was an impact. The professionals went into high gear. I don't know if Hubble got any pictures. Yeah, I guess they did get 1 or 2, but they rarely get pictures of Jupiter anymore. And but amateurs and professionals around the world really got into this And they put together a montage of amateur images over a 2-month period. You can see it starts there and how it spreads out with the cloud band. This polar view, looking down at the south pole of Jupiter. There's a fellow in Germany who put these together. There's about 20 different amateurs involved in this. And you can see the clouds. Oops. Wait a minute. Go back. Oh, no, what have I done now? Oh, my God. Oh, no. Okay, let's try this again. I'm just going to leave that going back because this thing just had a nervous breakdown. Okay, anyway, so every 1,000 to 2,000 years we figure we don't have any more impacts. And then the next year, a year later, June 3rd, 2010, Anthony Wesley again. Oh, by the way, that was called the Bird Strike. That was I was going to point out. His nickname is Bird. So they call it Impact the Bird Strike. Anyway, he was imaging Jupiter, and he saw a bright flash. Now, normally when someone would send you a picture like this, first of all, you'd say, oh, you got a hot pixel on your CCD screen, see? Well, of course, he was taking a webcam picture, so he had that hot pixel in the same place on about 7 images consecutive. So that was kind of suspicious. I don't have his AVI because it was really long and I couldn't get my computer to run it. But Chris Go again in the Philippines. This isn't working. Oh, there it is. See, I don't know if you saw that. Let me go back at the risk of ruining this whole thing. And all right, just watch here. There it is. Chris, that was Chris's image of that impact. It's upside down, but I couldn't turn the thing either upside down, so what the heck. But anyway, Chris saw that same thing. Come on, stay with me, that's it. And he called Anthony, and this is exactly the same time. They saw exactly the same flash, and it lasted about 1 to 2 seconds. So it was verified that it was an impact hitting Jupiter. It's amazing. Now these are color images. I think Chris's image was in blue light, and Anthony's was in red light, whatever filter they were using at the time, but it didn't make any difference because that's the runs they used, and they made pretty pictures out of them later, but just incredible. Simultaneous observation of an impact on another world. Okay, that was in July or whatever. Now August 20th, along comes another one. This is a fellow named Masayuki Tachikawa in Japan, and he reported using a 5-inch, 6-inch refractor and a 2U cam. I hope we don't get messed up again with the thing. Yeah, of course we are. All right, there it is. Did you see that? Let's try it again. I guess I won't wreck the machinery, but okay. There we go. There it is. Neat, huh? Okay, so that was another impact. Now, again, the world went crazy. We were looking at Jupiter for, all those dark features and see if the ash material got, there was nothing on any one of these. So the bottom line is that these things were probably fireballs, like we'd see here, except really, really big fireballs. But so now we're seeing meteors, impacts Jupiter. We're seeing fireballs in Jupiter's atmosphere. And the latest thing is that when you're, I always, big hint, when you're imaging Jupiter and you're sitting there on your computer screen, undark adapted, watching TV, as I do, having a beer in the other hand. Well, yeah, I mean, you got to, hey, absolutely. You're looking at Jupiter, look at the screen while you're recording, because you may see one of these events happen. And when you just record, walk away, come back, put all the stuff in Astrostack or Registack, you never see the individual images, you're going to miss it. So just kind of watch it, and you make sure your computer has a proper timestamp. Anyway, the gas giants, much like eating at a Chinese restaurant, always have surprises. Says that wasn't chicken. That wasn't chicken. It was in the fortune cookie. Yes, I love that. Anyway, here's a picture. Now we're getting up to 2010, and this is an image of Jupiter taken by Tomio Okutsu, also in the Philippines. And you say, wow, that's a lousy picture. I mean, whoa. Okay, well, Jupiter was 10 degrees above the horizon. This was at the very beginning of the apparition. These guys are serious around the world now. It's no more of this, take some pictures and process them next month and send, do it right now. And as soon as Jupiter's up, the sun gets out of the way, they're shooting this thing. And Tomio noticed something, that it was missing a belt. And holy mackerel, Jupiter has lost his belt. It's like this. Anyway, so along comes Damien the mosquito killer. Damien Peach spent a couple of weeks down here in South Florida 3 years ago. And he really didn't like mosquitoes, so he took a picture of them like this, you know, all the anti-mosquito apparatus. He took this really amateurish, lousy picture of Jupiter. That's, oops, wait a minute. That's Ganymede, that's Io, that's no South Equatorial Belt, red spot, and about 8 million other bits of detail. He was in the Barbados when he took this, this shot. But Jupiter's lost its South Equatorial Belt, is the bottom line. Here's another Brian Combs from Georgia, who just does absolutely beautiful work, and he did a little animation of Jupiter not having its belt with Io transiting the planet. Whoa, just amazing, isn't it? Okay, so what happens here? That's another, oh, this is by another guy from Georgia, Gary Walker, who just really new into imaging. And this is Callisto down here, a very dark moon, but nice stuff. That's Gary there with his 10-inch refractor, wow. And he said, oh, I have a 10-inch Muon, which is what I have. And he said, you know, he was asking me questions about a year ago about how to image things. He said, I have a 10-inch refractor. I said, oh, refractor's no good. You want a reflector. He's taking pictures like that now. So it's the last time I give anyone advice. Okay. These are SEB fades, they're called, South Equatorial Belt fades. And they're caused by that ammonia crystal, remember that layer I told you about? It just kind of hangs over the South Equatorial Belt. The great red spot also tends to darken during these periods. And you still see the South Equatorial Belt in ultraviolet and in methane light, just not in visible light. So these dry winds tend to die down. Jupiter has meteorology and climate just like any other planet. So the winds that will cause this downdraft tend to die down, and the ammonia builds up over the South Equatorial Belt, and we're talking, you know, 1,000-mile thick layer. This is a big deal. So the belt goes away, and then it will come back. It's called a revival. And the last was in 1993. There have been about 15 documented since, 1919, maybe some in the 1800s. But usually it's the South Equatorial Belt that goes away, and when it comes back, it comes back with a boom. I took these back in 92. That was the Lynx again. Maybe I should resurrect that. There's better pictures than I do now. This is the way Jupiter normally looks, with the two dark belts and the great red spot, you know, not really all that dark and all that. That was the whole year of 1992. And in 1993, the South Equatorial Belt went away. Here it's just starting to come back. But basically, that was the last revival. So when this happens, the reason it's exciting, it's one of the most explosive and violent events in the solar system, the SEB revivals. And it usually begins with a bright eruptive spot, and dark material then sort of violently tunnels along through that layer of ammonia ice crystals, 1,000 miles deep, and eventually will circle the planet, which is 270,000 miles around, and the belt, you'll be able to see it again, it reforms. But there's all kinds of upwelling, massive, you know, like we get a thunderstorm here and you can see the updraft, you think that's really something. Imagine one 3,000 miles going up at many meters per second. Anyway, okay, so there's weird stuff about these. They usually start at one of three longitudes. Jupiter's gas, but we know the longitude, you know, because of the convention we use with System 1, System 2, and all that. Anyway, Elmer Rees comes out again, and he kind of said that back in the 50s. He said, you know, it's like longitude this, longitude that. There are three vents seem to be on Jupiter where these revivals will start. This stuff comes belching up. Well, you know, we don't know why, and everybody kind of ignored him until they came out with the radio System 3. Elmer went back and got his data, and they exactly match. And this particular episode started precisely at one of Elmer's vents, you know. And why that is, we don't know. I mean, there's not supposed to be any solid surface. There might be a solid surface thousands of miles beneath the cloud deck, but we're not really sure. It is giving us a glimpse of maybe of what's going on inside of Jupiter's violent interior. And speaking of the SEB revival, it's time to get going again. Christopher Goh appears, and he, November 9th, 2010, he sees this little dot, okay? Yeah, pretty unimpressive. So Chris gets all excited. He's a real student of Jupiter. Chris gets all excited. He calls me on the phone from the Philippines, which is quite nice. And he's keeping it in, our usual. And he said, Don, I think we got a revival going on. So I got out an image